Welcome to the Explainer. I'm absolutely thrilled you're joining us today. If you're a focused learner looking to just cut through the noise and get straight to the facts, you are in the perfect place. Today, our mission is to tackle a subject that honestly trips up even seasoned marine engineers. We're talking about SOLAS steering gear regulations. Now, if you've ever tried reading The Safety of Life at Sea or SOLAS Convention directly, you already know it's incredibly dense. I mean, unless you happen to enjoy reading hundreds of pages of legal maritime jargon for fun. But hey, that's exactly what we do here. We're going to take all that heavy legal jargon and translate it into clear, structured, and totally practical engineering rules. By the end of this explainer, you're going to have a rock-solid grasp of exactly what keeps these massive vessels steering safely across our oceans. Okay, let's just dive right into our roadmap for today. We're going to cover 5 main things. First, the SOLAS baseline rule. Second, main versus auxiliary steering. Then, we'll scale up to heavyweights and tanker rules. After that, surviving system failures. And finally, bridge controls and automation. All right, let's kick things off with Section 1, the SOLAS baseline rule. Before we even think about massive tankers or complex backup systems, we really have to understand the fundamental engineering parameters that govern literally every single conventional ship out there on the water. And the absolutely crucial point here, it's the number 28. This is the golden rule of marine steering. Basically, the main steering gear of a vessel must be capable of moving the rudder from 35 degrees on one side over to 30 degrees on the opposite side within exactly 28 seconds. Now, you might be wondering, wait, why not 35 to 35? Well, as the rudder swings past that 30-degree mark, the timing actually stops. This accounts for the mechanical deceleration of the gear. But remember that threshold, it's absolutely crucial. 35 degrees to 30 degrees in 28 seconds flat. That's your benchmark for performance. So, how do we actually prove a ship meets that 28-second rule? I want to bust a super common exam myth right here, right now. You absolutely cannot test the steering gear timing with the ship just sitting at a standstill in port with zero load on the rudder. Nope, that is simply not compliant with SOLAS. The test actually has to be conducted under 2 absolute extreme physical conditions. First, the vessel's got to be running ahead at its maximum service speed, and second, it must be loaded to its deepest seagoing draft. Why? Because this ensures the rudder is actively fighting against the maximum possible hydrodynamic resistance it's ever going to face in normal operation. Moving right along to Section 2, main versus auxiliary steering. Look, mechanical things break, right? That's just a universal truth of engineering. So what actually happens when the primary system goes down right in the middle of the ocean? Well, the difference in expectations between everyday performance and emergency survival is frankly massive. We already know the main steering gear is this high-performance system doing that 35 degrees to 30 degrees in 28 seconds under maximum load. But the auxiliary steering gear, the backup, that is strictly for emergencies. It really only needs to move the rudder from 15 degrees on one side to 15 degrees on the other, and it gets a full 60 seconds to do this. Plus, the ship only needs to be moving at a navigable speed of 7 knots, or half its maximum speed, whichever is greater. So it's not designed for high-speed maneuvering, it's just designed to keep the ship safe, keep it under basic control, and, well, get you home. But hey, shipbuilders absolutely love efficiency. And SOLAS actually offers a pretty neat alternative to having a completely separate auxiliary gear just sitting there taking up valuable space. Instead, you can simply install 2 identical power units, which are usually hydraulic pumps, right on the main steering gear. The rule here is that together, operating at the exact same time, they've got to meet that heavy-duty 28-second rule. If one fails, no big deal, the other just acts as the backup, meeting those slower auxiliary requirements we just talked about. But wait, notice the specific safety exception made for passenger ships here. Because, human lives are on board, the rules get way stricter. For a passenger ship, just one of those pumps must be capable of meeting the 28-second rule completely independently. All right, let's step it up. Section 3, heavyweights and tanker rules. So we're scaling up from your average cargo ships to the really massive vessels now. And because of their sheer size and the hazardous cargo they carry, SOLAS drastically tightens the regulations. Now, a heavyweight under these specific SOLAS parameters isn't just some subjective term. For general cargo and other standard vessels, the threshold is basically anything over 70,000 gross tonnage. But look at this massive drop for oil, chemical, or gas tankers. For them, the really strict rules kick in at just 10,000 gross tonnage. The potential environmental disaster of a tanker like that losing steering is so severe that SOLAS simply doesn't take any chances. And what's truly fascinating here is how the redundancy rules change for these absolute giants. So for a standard ship over 70,000 GT, you can't just rely on combining two pumps to meet that 28-second rule anymore. Nope. Each pump must be massive enough to independently handle the entire 28-second load all by itself. But for tankers over 10,000 GT, oh man, it's not just about the pumps anymore. They actually need two essentially independent steering systems. And if a failure occurs, the system's got to feature something called auto-isolation. Which brings us perfectly to Section 4, Surviving System Failures. So what exactly does auto-isolation mean, and why is it considered the ultimate fail-safe for a modern oil tanker? Let's picture this. Imagine a high-pressure hydraulic pipe suddenly ruptures on a tanker's steering gear. I mean, within seconds, hydraulic fluid is just pouring out. That's step one. Step two, sensors instantly detect this super rapid loss of fluid level. Step 3, automatic isolation valves trigger immediately. We're talking zero human intervention here. The system literally just cuts off the leaking half of the steering gear on its own. This stops all the fluid from completely draining out. And finally, step 4, steering capability is actively maintained using the remaining intact half of the system. This entire sequence happens in mere seconds. It is a brilliantly designed mechanical failsafe that has, without a doubt, saved countless coastlines from devastating oil spills. But wait, what about the older ships? The ones that were built way before these strict auto-isolation and double actuator rules were even written? Well, SOLAS actually accounts for this specific edge case. Older existing tankers over 10,000 GT can actually be granted an exemption from retrofitting an entirely new dual actuator system. But, and this is a huge but, only if they fully comply with SOLAS Appendix G. And let me tell you, that requires rigorous alternative documentation, really intense testing, and totally meticulous monitoring just to prove that their existing single actuator system is overwhelmingly reliable. So it's definitely not a loophole. It's an incredibly high bar for alternative compliance. All right, rounding the final corner here with Section 5, Bridge Controls and Automation. We've spent a lot of this explainer down in the steering gear room, right at the back of the ship. But now, we really need to connect those massive mechanical hydraulics directly to the captain's fingertips. The bridge has to remain informed and in control at all times. For those tankers over 10,000 GT we talked about, you don't just need redundant hydraulics, you actually need two entirely independent control systems, running all the way from the bridge down to the steering gear. Plus, the bridge has to have immediate visual and audible alarms for literally any power failure to the steering gear. I mean, the absolute second a pump trips or power is lost, that alarm has got to sound on the bridge. And crucially, there has to be an automatic pump restart protocol in place. And that specific protocol brings us to our final, super crucial number, 45. In the absolute terrifying event of a total blackout, where the ship literally loses all its main electrical power, the emergency generators are going to kick in. But once that emergency power is restored, the steering gear pump must automatically restart and be fully operational from the bridge within exactly 45 seconds. Think about that. 45 seconds to regain control of thousands of tons of moving steel. It really just highlights exactly how critical steering is to the immediate split-second survival of a vessel. So we've seen exactly how SOLAS uses precise timings, really strict tonnage thresholds, and these incredible automatic mechanical failsafes to govern safety at sea. But it leaves us with a pretty fascinating question to ponder. As digital automation, AI, and even autonomous shipping advance at this absolute breakneck speed, how in the world will these deeply physical mechanical SOLAS failsafes evolve to protect the incredibly complex ships of the future? It's a massive design challenge, and it's one that the next generation of marine engineers is going to have to solve. Well, thank you so much for joining me on The Explainer today. Keep learning, stay curious, and I'll see you in the next one.